Example 9, the pump is to deliver to the pipe outlet at elevation 20 meters through a 900 mm diameter pipe at a flow rate of 1,315 liters per second. So these are the pipe details, different pipe details. How much water must the pump supply? The discharge that the pump must supply to the system. Determine the horsepower of the pump if the efficiency is 80%, and what is the pressure head in feet of water before the pump. So this is the situation. Knowing the discharge in DF, we can compute the head loss in DF, then the energy level at junction D to locate the energy level so that we can compute for the head losses of the other pipes. So HF DF is 0.0826, friction factor is 0.02, length 2,500, discharge 1.315 square over diameter 0.9 raised to 5. So HF DF is 12.09 meters. So this is 20. That's the energy level. Then the vertical distance is that 12.09. And therefore, 20 plus 12.09, that's the elevation of B. So that this is lower than elevation 40. So the flow direction would be towards the junction as well as for GD. And this is the discharge that this pump must supply to the system in that direction as well as for AB. QAB is equal to QCD because they are in series. So this is at elevation 32.09, elevation 20 plus 12.09. So head loss in ED is 40 minus 32.09. That's 7.91 meters. While the head loss in GD is 80 minus 32.09. That's 47.91 meters. So let's solve for QED. 7.91 equals 0.0826, friction factor 0.022, length 1,500, discharge QED square over diameter 0.4 raised to 5. So discharge in ED is 0.1724 cubic meter per second. Next, let's solve for QGD. 47.91 equals 0.0826, friction factor 0.02, length 2,000, QGD square over diameter 0.5 raised to 5. So QGD is equal to 0.6732 cubic meter per second. So from the figure, QCD plus QED plus QGD equals 1.315. So QCD plus 0.1724, QED plus 0.6732, QGD equals 1.315. So the discharge that the pump supplies can now be computed. It is equal to 0.4694 cubic meter per second. Determine the horsepower of the pump if the efficiency is 80%. So we have to determine the head added by the pump. Power output is Q gamma Q times specific weight of water times head added by the pump divided by 0.746. We want discharge to be in cubic meter per second and unit weight of water 9.81 kilonewtons per cubic meter. So the power input is Q output over efficiency. So we divide further by efficiency, which is 0.8. So head loss in pipe CD is equal to 0.0826, this one, friction factor 0.09, length 2,500, discharge 0.4694 square over diameter 0.6 to the fifth. So head loss is 11.12 meters. So that's the head loss. The piezometric level at C, because the flow direction is towards D, should be higher than 32.09. So that's C prime. I call that C prime. Then the vertical distance between these two energy levels would be 11.12. So the elevation there is 32.09 plus 11.12. And that is equal to 43.21 meters. Then we compute the energy level at B by computing the head loss in pipe AB. HFAB equals 0.0826, friction factor 0.09 also, length 1,500, discharge the same 0.4694 square, over diameter 0.6 to the fifth. So head loss is 6.67 meters. Therefore, the energy level at B is 25 minus 6.67, and that is, let's show the direction of flow. So this is 6.67, therefore the elevation there is 18.33 meters. Then the difference in elevation between 43.21 and 18.33, that's the head added by the pump. That's the energy grade line, and the flow direction is going up because this is the head added. The head added is 43.21 minus 18.33. So it is 24.88 meters. That's the pumping head. And then we compute for input power, output over efficiency. Horsepower input is Q gamma of water, head added, over 0.746 in horsepower, then divided by efficiency, it becomes input horsepower. So it is equal to 192.0 horsepower. Finally, take note, this is the energy grade line, so therefore energy is 18.23 meters. For the pressure head, we subtract the velocity head at B, which is 4 times this. Velocity head is velocity at B square over 19.62. So the velocity at B is 4 times discharge, 0.4694 over pi diameter square, 1.66 meters per second. Then square divided by 19.62, that would be 0.1404 meters. Since the pressure head must be expressed in feet of water, so the pressure head therefore is 18.33 minus this velocity head. Remember, the pressure hydraulic grade line, the difference between hydraulic grade line and energy grade line is the velocity head. So the pressure head at B is 18.33, total energy minus velocity head, then times 3.281 feet per meter. So pressure head at B in feet is 18.33 minus 0.1404 times 3.281. So the pressure head at B is 59.68 feet.